Hi there, my name is Matthew McGrath, and today we're going to talk about Git in the command line. Git is what's called a distributed version control system, or in other words, Git is a system for keeping track of changes to files over time. In this video, I'm going to explain how to use Git from the command line. But before we get to explaining more about Git, we need to talk more about the command line. So, let's think of your computer like a car. For most people, when they sit down in their car, they grab the wheel, they accelerate, and that's it. There's nothing else to it. But for the engineers who work on the cars, it's important that they can keep track of what's going on while the car runs. It's their job to monitor, assess, and interact with the car to make sure it's running properly. For us as computer engineers, it's important that we can do the same. And that's where the beauty of the command line comes in. The command line, the terminal, the shell, those are all generally used to refer to the same thing, a command line interface that users can use to interact with their computer. There are different versions of the command line for different operating systems. For example, for Windows, you have PowerShell. For Mac, you have Z Shell. And then for Linux, you have Bash. Generally speaking though, despite minor differences, the purpose of the command line remains the same for all operating systems. It allows a user to have a more tactile feel for what's going on inside of their computer. The command line can also be super efficient. For example, this is a video of me installing VLC Media Player from the terminal versus doing it using a web browser. As you can see, the command line is a powerful and efficient tool for interacting with your operating system. That being said, with great power comes great responsibility. And if users aren't careful, it's possible they might damage their systems. So it's good to start small and work your way up. I can actually attest to this personally. When I first started using the Linux operating system around 2 years ago, I had no prior Linux experience. Since I wasn't learning formally, I was mostly teaching myself with online internet guides and going on Stack Overflow to look up questions I had. On one occasion in particular, I typed the unforgivable Linux command. It's basically like the unforgivable curses in Harry Potter, but just for the command line. It's sudo rm-rf/. This command tells the operating system to recursively delete itself from the root directory. You nuke your system, there's no coming back from it. Now I don't know who posted that on Stack Overflow as a legitimate answer, because I did it and it destroyed my operating system. Luckily I was able to reinstall it, it was good practice for me, but whoever you are, I'm gonna find you. Your days are numbered. I can go on and on about the command line. I love the command line. But for the purpose of this video, since we're focusing on Git, we're going to talk about the command line in the context of Git. We already established that Git is a system to keep track of changes to files over time. But how does it actually work? So right here, as you can see on my screen, I have a folder here. It's called test folder. I have hello.txt, I have horse in the house, and worm. These are my files. So I've navigated here in my terminal on the command line. And we're going to begin to interact with this using Git. So to get started with Git, we're going to do git init. And what this does is this creates a Git repository for this folder. All of the diffs or changes are recorded inside this Git folder. So as we change our files over time, the differences are going to be stored here in this Git folder. Alright, so now that we've initialized our Git repository, I'm going to start making some edits to some files. So we're going to edit the hello.txt file here. I'm going to say I love Git, and then my name is Matthew. We're going to save those changes. Okay, so I'm going to do git add period. What this does is this adds the files that I've changed to the staging area. Then we can do git status. This shows us our modified file hello.txt. This file is staged right now and it's going to be committed. Then I run the git commit command with a message saying what I'm doing here. So I'm going to say modified hello.txt. Okay, I just did my first commit. When I do this, it's like I'm taking a snapshot of my files in case I need them for later. This is what's known as a commit. As we continue to edit our files and make commits, each commit represents our files at a specific point in time. We can kind of visualize this by drawing a flowchart. Each commit also has a link to the commit before it. Because of this, we have the ability to undo or restore our files to a previous version. But why is this important? If you've ever written code before, you know that it's often not a straightforward process. More often than not, you have different groups working on different parts of the codebase all at once. This has the potential to get really messy, and that's where Git shines through with a thing called branching. To demonstrate, I'm going to make a branch using the git branch command. And I'm going to title it horse because I have this really cool horse picture that I really want to edit. If I type git branch, I can see that my horse branch was successfully created. As you can see here though, we have master selected. Master refers to the branch that we've been on up to this point. It's the branch that's automatically selected when you make a Git repository. Now that we have our horse branch though, I'm going to switch to my horse branch by doing the git checkout command. What this does is this separates me from the master branch and lets me safely change files with the peace of mind that my changes aren't going to break anything for anyone else. We can change our files and commit to the horse branch as much as we'd like, and nobody on the master branch is going to be affected by it. You can think of it in terms of an actual tree branch. If we're up in a tree and I'm on my own branch, it doesn't matter what I do. I could even cut my own branch and it still wouldn't affect you. This functionality that Git has is essential for large projects. For example, large social media sites and video games, they often have testing branches to test new updates. As a matter of fact, Git workflows that companies use often have several branches for all sorts of different use cases. Which brings me to my next point. Once we're satisfied with our changes, it's time to merge the horse branch with the master branch. To do this, we do git checkout master. Then we do git merge, and then the name of our branch, which is horse. This merges our horse branch with the master branch and makes them one and the same. If you cloned your repository from an online hosting service like GitHub, now would be the time that you do the git push command to sync your changes with the online repository. To be honest, this is really only the tip of the iceberg, and there's a lot more that Git can do that I'm not even covering. If you have more questions, there's lots of excellent resources online to help. That being said, I hope you enjoyed, I hope you learned something. That's about all for now. Thanks for watching.